In this video, we'll discuss how to solve quadratic inequalities. Now, we'll do this two ways. We can do it algebraically, where we're trying to determine all the values for which the quadratic inequality is true, and we can do it graphically, where we're looking at all the shaded values that exist on the x-axis. Now, we use the shaded values on the x-axis because that's when the y value equals 0. Our solution will be created in two ways. First, we will put it on a single number line, and then we will turn that into its interval notation. Let's start with the graphic method for solving the quadratic inequality. When we do this, the first thing we're going to do is write the equation in general form. And I've left this kind of open blank here because the inequality will change with the given problem. Then we're going to replace that 0 on the right-hand side with y and graph the inequality. Now, when we're doing that, if we're not using a program like GeoGebra or Desmos, it will be helpful to determine where the shading should exist. So we can use the point 0, 0 as a very easy point to use to determine the shading. If 0, 0 is true, we shade everywhere that 0, 0 exists, whether it's inside or outside the parabola. If 0, 0 is false, we're going to do the opposite of where 0, 0 is located. Now we're looking everywhere on the graph in which the x-axis is shaded because, again, that's when y equals 0. We will put that on the number line, remembering that solid circles are for the equals to component and hollow circles are for just greater than and less than. And when we write the interval notation, we use brackets for the equals to component and we use parentheses for the less than or equal to, or less than or greater than component, as well as for the infinities, because you can never actually get to an infinity. So let's try some examples. First, we have x squared minus 15 is greater than 2x. First thing we'll do is write that in general form. So we're going to subtract 2x from both sides, and that will give us x squared minus 2x minus 15 is greater than 0. Now to graph this, we're going to replace the 0 with y. Now look how I have changed this inequality. If you see here, I've written this as y is less than x squared minus 2x minus 15, whereas this one says x squared minus 2x minus 15 is greater than 0. But all we've done is said that the inequality must open towards the x squareds, and I've written it in a way that we often will graph. I can plug this now into any program I have, and I'll see that my graph should look something like this, with a hollow dot at negative 3, 0 and at 5, 0, and the parabola itself should be dotted lines. Now if I want to verify my shading, I can use 0, 0, which falls inside the parabola. So 0 is less than 0 squared minus 2 times 0 minus 15. 0 is less than negative 15, and that is not true. So I would not shade inside because these values are not true. It has to be everything on the outside. Now I can start to determine my solutions. So if you think about the coordinate plane as both the x and y axis, for the number line, all we care about is the x-axis, which goes from negative 3 all the way to negative infinity and positive 5 to positive infinity. And that's what it'll look like on a number line. We start at negative 3 and shade to the left. We start at positive 5 and shade to the right. We use the open circles because this is an inequality that does not have the equals to component. Now we can use our number line to put it in interval notation. We do our interval notation left to right. So since it shades forever to the left, I can go all the way to negative infinity. So that's the parentheses negative infinity. I keep going until I have to stop, which is here at the open circle, which is at 3. So it's a parentheses at negative 3. And then I have to use the union symbol because I've got to do this other one as well. Then it starts again at positive 5, and that's parentheses because of the open circle, and shades to the right forever, so that's to positive infinity. And there would be my interval notation. Now let's look at another example. Say that we have x squared plus 8x plus 12 is less than or equal to 0. This one is already in general form. So now I just need to plug in the y and realize that since this is opening towards 0, my inequality needs to open towards y. So y is greater than or equal to x squared plus 8x plus 12. Now I'm going to graph that, and I see that the shading falls inside the parabola. It's a solid parabola with with solid dots at -6 and at -2 on the x-axis because of the equals to. Again, I can verify my shading by using the point 0, 0. And when I do that, I get 0 is greater than or equal to 0 squared plus 8 times 0 plus 12. 0 is greater than or equal to 12 is not true, so I would have to shade the opposite. Since 0, 0 is on the outside, I shade on the inside. Now I need to look at that and determine my solutions. So I'm looking then wherever it's shaded. It starts at -6 and goes to -2. This is the only part that's shaded, so that's what I would shade on my number line. So I put the solid dot at -6, shade to the right until I get to the solid dot at -2. For the interval notation, since those are solid dots, I use brackets, starting on the left side from -6, going to the right side at -2, and again another bracket. And there's my number line solution and my interval notation. Now I can also do this algebraically. If I'm doing it algebraically, the first thing again, put the inequality in general form. Then I'm going to solve the inequality as a quadratic equation. And that can be done either with factoring or the quadratic formula. Then I put those solutions on the number line, and that should split our number line into 2 or 3 sections, typically 3 sections. And what I'm going to do is choose an x value in each of those sections to see whether it makes the inequality true or false. If it makes it true, I know I should be shading there. If it makes it false, I know I should not be shading there. So I graph only my solutions that are true. And again, solid dots for the equals to, open dots if it's less than or greater than. And then when I do the interval notation, same thing, brackets and parentheses based on the type of inequality. So let's go back to our 2 examples we had already. So before, we said we first put this in general form by subtracting 2x. We did this before and got to x squared minus 2x minus 15 is greater than 0. Now, if we're doing it algebraically, we're going to treat this as an equality and factor to solve for this quadratic equality. So I'm looking at what factors of -15 sum to -2. That would be -5 and 3. So I'm going to use group factoring here and say this is x squared plus -5x plus 3x plus -15. I group my first 2 terms and my last 2 terms. I factor out an x in the first group. I factor out a 3 in the second group, leaving me with x minus 5 inside each groups. So I've got x minus 5 and x plus 3. So I solve each of these for x, and I find that x is 5 and x is -3. So there I've done that first step, which is just to figure out what are those 2 points that are going to separate my number line. The next thing is I'm going to test points on the number line by first creating the number line and placing these 2 points on it. And since this is a greater than inequality, I use the open circles. So now I'm going to test this section, and this section. So if I look to the left of my open circle, I can try any of these points. I decide to try -4, which is the very next integer that occurs. So I'm going to take -4 and substitute it into my inequality. -4 squared minus 2 times -4 minus 15 is greater than 0. I simplify that. Then I got 16 plus 8 minus 15. That gives me 24 minus 15 is greater than 0. 9 is greater than 0. That is true. Since that is true, that means shading will occur to the left of my open circle. Now I'm going to test the middle section. And since 0, 0 is there, I'm just going to use 0. That's the easiest number to always use. So 0 squared minus 2 times 0 minus 15, that's going to be 0 minus 15, which is just -15, is greater than 0. That is not true. That means no shading should occur between my 2 points. Now I try a point to the right. So in this case, I'm going to use 6 since that's the very next integer here. So 6 squared minus 2 times 6 minus 15. That's 36 minus 12 minus 15. So 24 minus 15 is 9. And again, that is true. Since that's a true statement, I shade everything to the right because I know those values are going to work. And that's my number line. I've created it by testing the 3 separate sections. Now that I have my number line, I can create my interval. Again, it goes all the way to negative infinity, so that's where I start. Looking to the right, I stop at -3, but I see I've got more, so I need to put the union symbol. I start again at 5, but it's an open dot, and I shade all the way to the right to infinity. And there I have both my number line and my interval notation algebraically. Now let's look at the other example and look at it algebraically as well. So again, the x squared plus 8x plus 12 is less than or equal to 0. That was already in general form, which makes this a little bit faster. So now I just need to solve x squared plus 8x plus 12 to figure out what are those 2 points that I want to put on my number line to help me get started. So I say what factors of 12 sum to 8? In this case, that would be 6 and 2. So I'm going to use my group factoring. So x squared plus 6x plus 2x plus 12. I group my first 2 and my last 2. First group, I factor out the x. Second group, I factor out 2. And that leaves me with x plus 6 in both groups, which is exactly what I want. So I have x plus 2 and x plus 6. I'm going to solve each of my factors. And I subtract 6. And I subtract 2, and I'm going to get x is -6 and -2. So I know now where on my graph, on my number line, I should be putting my points. So now I'm going to place the points on the number line and then test in each of those sections. So I'm going to place it at -6 and -2, and they're solid dots because this inequality has the equals to component. So let's test to the left. To the left of -6 is -7. So -7 squared plus 8 times -7 plus 12. That's 49 minus 56 plus 12. That's -7 plus 12. And this is saying that 5 is less than or equal to 0. That is not true, so there is no shading to the left. Now let's try a point in between. So a point in between -6 and -2, I chose -4. You could choose -5 or -3 for another easy integer. So -4 squared plus 8 times -4 plus 12. So that's 16 minus 32 plus 12. So -16 plus 12 gives me -4 is less than or equal to 0. That is true. That means my shading will occur in between. Now I need to check this right-hand side. And again, I use 0 because 0 is an easy number. 0 squared plus 8 times 0 plus 12. That gets me to 0 plus 0 plus 12, which is 12 is less than or equal to 0. That is not true, so I can't shade over here. None of this will work. So my only shading is right here in between. So my interval then, this is a solid dot starting at -6. Going to the right, it stops at another solid dot at -2. So it would be from -6 to both of them with brackets.